Hi everyone, welcome to MathSpellBook. I'm your host Peter, and basically we're going to get into some differential equations today. Hopefully you guys are having a good start to your week. It is Monday, and you know, it's still summertime here in this here in the States, so if you're like watching this from the States, hopefully you're enjoying your summer vacation. I don't know if it's summer vacation for anyone else around the world, but hopefully you're having a good break if you're experiencing break from like school or university, whatever. Okay, so I thought we would basically start by doing some Laplace transform problems. Oh, I need to actually get a better sheet because this is the inverse Laplace transforms. I need to get the regular Laplace first. No, this is not it. Where is it? Oh, here we go. Laplace transform sheet. Now, I'm not showing the sheet because obviously it's from like one of the courses that I'm taking. So I thought that I would basically just do the questions for you guys. So, but I'm not going to show the sheet. I'm just basically going to like write down the problems as we go. So hopefully you guys will enjoy. Oops, I forgot I reset this, so I actually have to set it up. I don't know why Excel Draw does that. It always sets it to the most thickest of fonts. Well, it's not really a font, it's just basically just thickness of the pen. Okay, finding Laplace transforms. I did learn a little bit of them, so I thought this would be a good opportunity to practice. So I guess like over the weekend I took a little short crash course in differential equations. Now of course it wasn't everything because they didn't cover anything like the Bernoulli or anything like once, but at least they covered like I guess like the basics of each section, such as like linear first order differential equations, in addition to like second order linear. And I think like that's where I can do the start off point, and then I can just expand my knowledge by just actually delving deep into the complex stuff in the books. So alright, so again F to T. So the Laplace transform of this one, I think it's, I'm just going to take a look at the table just to make sure, because I'm trying to memorize some of them, so that way, here we go. I think we got that right, because according to the table, T, the linear transform of that is this. And when we actually think about it, it's like 1 to the first power. Okay, so this is actually, like, I wouldn't say it's easy to remember, but I would think it's like a good benchmark. Okay, so we just drag this over here. Alright, so now we're going to do B. B's linear transforms. Oh, okay, so this one is the same thing, only this time we have to do and then S to the power of n plus 1. So in this case, we have to do, so it's 2 over S3. I believe that is our linear transform for this one, and that's our linear transform for this one. Okay. Yeah, I'm trying not to look at the table too much. I'm actually going to try to get myself a little bit kind of just like, oh, it says use the definition. Oh, okay, so I guess we'll go back. I guess we'll go back and we'll actually just try to apply it. So I think that's probably better, so that way we can get the definition in our heads. Hello, Jeff Gross. How's it going? Using you as a background noise while I code. No problem, no problem. As long as I help you get your projects done, then that's also good. So the definition of the linear transforms, I have to remember, because I think it is from 0 to infinity. F of t times e of negative st. I think that's how it works. Because I'm trying to remember the definition by heart, and I don't want to look it up like right away. Because I want to make sure that I'm actually, because I feel like this is the way it's set up. So alright, I'm going to take a brief look. Definition of linear, not linear, Laplace transforms. Okay, yeah, we wrote it correctly. Okay, my memory of it was much better than I thought. I thought I messed up somewhere. Okay, all right. So I guess we're gonna have to do it the hard way, and I think we're gonna have to transform this into a limit. So I think we're gonna take the limit as a goes to infinity, and then we're gonna have a. We're just using a as a proxy, and we're definitely gonna have to use integration by parts in this one. So we'll leave the limit out, and we'll just do the integration by parts. So u will be t, and du will be dt, and we'll have vd, dv, and v will be negative s. I believe that's how it works. Yeah, because we have to integrate it. Alright, so now we can write this. So the limit of I don't like the way that infinity symbol looked. There we go. Much better. So we have times t minus a, and we have for s dt. Like so, minus, and I think we can make this a plus because we take the minus over s. Then we're left again with negative s since from a to 0. So let's just clean it up a bit. So times t over s, and this one's a minus, so minus s squared. That's one part, and then a. So we have 0 and 0 here, 0. So in this part, we're left with 0 minus s2. Together so that we have ES oops, there we go. Then we do negative SA. Technically, that would all be mine. Well, actually, we can put a plus there. Now, when we actually see this, since this has a negative, it basically will be on the bottom. So if we rewrite this, so now we can actually rewrite it the way it's supposed to look like. Like if you guys don't know, like oh, there's a negative there. So basically, since we have a negative sign here, that means that this has to be, this ESA has to be on the bottom. So we have to have it like this. SA minus squared SA. Well, oops, negative sign is not supposed to be there. And then we'll do plus S2. So since this is going to infinity, that means these two are getting closer to 0, because obviously if it's in the denominator, then it's getting closer and closer to 0. So these two will definitely be annihilated, and then we're left with our final answer, which is this. Perfect. That's what we want to see. And I think we did that pretty well. I mean, it's a lot of work though. Of course, like they say, that pure definition of a Laplace transform is going to be a lot of work, especially like with all this. And this is only with t. And we have like a lot of other problems to go for, but we can do it. We can do it. It'll be tedious, but at the same time, we'll work with it. I think we're gonna work with like maybe another example, and then we'll probably move on to doing a little bit more stuff. Yeah, because I don't want to spend too much time on the long approach, so we'll do the next one, because you saw how much we had to do for like just regular t. Like, look at all this work. It's a lot. And if we did like the other ones, I think it would be like a lot more tedious to do. So do a t squared for this one. And if we remember our definition is, oops, not t, 0. It's supposed to be 0. 0, and then we'll have the function of t squared minus, okay? So now, what we have to do is take the limit. So when a goes to infinity, and then we'll change this to a, like so. And now, continue on. And I think we're going to do integration by parts, so we'll do equals t squared, and then du is equal to t dt. And then for dv, we'll obviously have, and then for v, we'll have s. So we can write this as s times du minus the integral of a to 0 e s t s, and then we're going to have to do integration by parts again. Oh. And I think we can basically just take what we got from the last one. So, because it's practically the same problem. Well, not technically, but we'll work it out anyway. So limit of a equals infinity. Squared. And now I think we're going to do integration by parts again. So I think we're going to have to do the simple approach, which is u equals and then dt. Yeah, because that becomes 1. And then, well, technically, we can just move. Technically, we can do this, make our job easier. So instead of, so then we're just going to be left with this, and then dv will be the same as what we got last time. Okay, that works out. So now we'll just add that by e ss times t, and then minus a and then we're going to be left with yes for s that up front, and then we're gonna do this, yeah, and then dt like that. And then we'll lower down here, so we'll just rewrite everything so it's not too squished. And then this. This point, oh yeah, there's supposed to be a negative sign here, so turn that into a plus, move that out, and then afterwards then we get another one over here. 0 to 1 right there. Okay. So now we gotta combine them all together so they can have one big, huge expression. So minus t, and then plus s times, I think we're gonna do s squared times that, and then we also have s3. Well, actually, let me just erase this. Yeah, because when we do the integration, it's going to be like that. So s4, and then e t, and then a. Okay, yeah, that should work, because when I'm thinking about it, so these will turn into A's, and they will go closer to 0, because obviously these are going to be in the denominator. Yeah, and this will also go to, like, I feel like I did something off here, because something is not right. Usually it's whenever I have to do integration by parts 2 times. That's when I start making mistakes here. So let me take a deeper look at what I missed. I think this is why a lot of people hate the longer problems, because like if it doesn't look right, then it's like a lot of backtracking, and the backtracking is usually the most annoying. Oh, okay. Now I see what I did. It was just a simple miscalculation here. Yeah, because then that would be 3. I don't know why I got 4 for some reason. That's what was wrong. Okay, so now we can... It's good to check. It's good to check. Luckily, I checked, because that is not right. I was like, there's something wrong with the calculation somewhere. So... I think we're going to write this the way this was supposed to be written. I don't like how my E's look like C's. A is 2. So T squared plus these would be like... So these will be 0, and this will be the only one. Actually, since that E is a minus, we can make that a plus. And so all these will go to 0, because if A is going to infinity, then basically all these are all getting to 0. This is the only one that's left, because like 0 to the E S, that would be 1, and it will be in the denominator. So that would be 1, and then basically that will equate to just this. So we'll just write that as... Cool. Okay, so I think we're gonna try to do another type of problem, because we did 2 Laplace transforms with the definition of Laplace transforms, and you saw how much work we did with just a t and a t squared. Can you imagine like what would happen if we expand that to like something else? That would be a lot more work. Because like, I mean, I think like knowing the definition is beneficial if you don't know what the Laplace transform is, but would I recommend doing it by hand? Probably not. Probably not. Okay, so I think what we can do is that we can do some second order linear differential equations. I think that would be fun to do. Now, of course, like many people think, wow, how is math fun? It can be fun. It can be fun. So, we'll probably do like both homogeneous and non-homogeneous differential equation, second order differential equations. Okay, now I don't know how many techniques there are when it comes to second order differential equations, but when I learned like that one technique I did from my differential equations crash course, it made it so much easier to like actually like simplify everything into like a technique that I can put in. So basically what you do is like you try to turn the second order differential equation into like a quadratic. Then depending upon which type of root you get will determine the solution that you're supposed to end up with. So plus and plus. So that means we're left with -2. And if I remember correctly, since we have 2 roots, that means we end up with y is equal to a. So this one is the least. Well, I didn't like the way I wrote that 3 there. So it's -3x plus b e to the -2 power. And that is the solution for that one. I don't think we have any initial value problems in the sheet, so we'll just continue solving these. We'll just jump around and we'll just jump around from homogeneous to non-homogeneous, and we'll see how it goes. I don't know, like, if anyone in chat like has taken differential equations before. Tell me what other methods I'm missing with second order differential equations. I know, like, I have to relearn Bernoulli, which is in first order. Okay, so we have 15, so I think we already know what this one is. 3 5. And since we have 2 roots, that means it will be a negative 5x plus b e. Okay. All right, next one. Let's see. And then plus. Ooh. This one is going to be a little bit interesting. So if we do m squared plus 5m equals 0, we can take out the m, and then we're left with, and then m will be, so technically this is already like 2 roots, but I think we're just going to end up with like 1 term here. Because technically this m would be 0 and this one would be negative 5. So since we're doing in descending order, I think that would be it. So okay, then minus 7. Alright, so we're left with 15 squared minus 7m, well 15m squared, and 7m minus 2. Okay, can we break this down? I think I can see a pattern, but hold on, I have to think. Because we have, I want to see if this works, and we do have minus signs, so that tells us a lot. So I think 2 would be here, and then plus 1 would be here. Yeah, because then okay. Sometimes like you just gotta slow down. Like you gotta slow down and just like take a look at how these things will work out. Because otherwise you can make a lot of foolish mistakes here. Okay, so this one we're gonna be left with 2. Yeah, we're gonna be 3 minus 2. And in this one we're gonna have 1 over 5 negative. Okay? Meaning we're going to be left with a to the negative 5th x plus b e to the 2/3 x. Perfect. All right. Going to the next one. It's pretty much the same thing, but I think like they separated depending upon what solutions you get, so I think these problems, like, once I got the hang of it, I started enjoying doing them because it's like, oh, it's just basically doing the quadratic formula all over again. So, m squared plus 10m plus 25. Oh, yeah, we know where this is going. So, yeah, it's practically just this equals 0, which means we're left with a multiplicity of, like, so, if that's the case, we are left with y is equal to e to the, and then a plus bx. Hey Sascha, how's it going? I mean, I feel like I'm doing pretty well. Are you winning? Are you winning, my friend? Especially with the hard maths? Oops, I didn't like the way I wrote that. Come on. My pen's supposed to write. Let me write. But how's it going, Sascha? How's it going? Plus y. And for all those on YouTube, thanks for getting me up to like past 100 subs. I really appreciate you all. Because I was like, when I looked at the amount of, like, I know the numbers are not important, but at the same time, like, once we passed 100, I was like, oh wow, like, I got like a lot of people that like math, and it's just very humbling to know that like you guys are watching, even though I'm just fumbling through these problems. So appreciate you all, like, just basically like watching me like do my progress in math as well as physics. So we're left with this, and then +1, meaning yeah, so that means, oh, I think this is just gonna be a simple m + 1 squared, and then -1, meaning that we're gonna have e to the minus x, a plus bx. Okay. Yeah, I think once you get, like, I think with math, like, once you get over the hurdle of, like, certain problems, you begin to, like, I mean, some people do like to enjoy it more because it's like, oh, I can do these problems now. But then they have to go to the next step and actually challenge themselves with the next thing. And of course, like, the thing of it is that some teachers are strict and they basically give you super hard problems. And, you know, like, some students hate that because it's like, I just barely got through the basics. And then, like, I know why teachers do that. They do that because, like, oh, like, you know, if they're a good teacher and they want your growth in mind, but they don't show you that they're putting your growth as a priority, they will give you harder problems just to, like, push you to the limit. And some people hate that, and some people, like, are encouraged by that. So I think it depends on the person's learning style. For me, I like a good balance of both, where it's like, I like the teacher to basically say they believe I can do it. At the same time, they gave me problems that could probably go over my head for a bit. But as long as they give me the assurance that I could do it, then that's the thing that I really probably would need. Because if it's a person that basically doesn't believe in me, or doesn't show that they're like, or doesn't show interest in my growth, then like to me, then I feel as if, like, I ask myself, why am I even doing this? And, like, yeah, that will be that sting where it's like, if I walk away from the person that is actually teaching me, but if they don't show that they believe in my skills, I end up just walking away, and I will feel that burn of, like, oh, this person's a quitter, they will never amount to anything. Like, you know, that weird feeling where it's like it's like that feeling you've given up and you feel bad because it's like you walk away from it, but you realize that it's not, it doesn't feel like you're being, it feels like the risk are not worth the odds, if that makes any sense. -7, so... And I think, like, a lot of math teachers are like that, because some of them are just, like, so good at math, but they're not really great at everything else, and they just basically put everything within, like, their lessons, and they try to give their students the most hardest of classes, because it's like, oh, this is the only way for them to actually learn what the true harshness of mathematics is. But at the same time, they're kind of making students walk away from it, because it's like, they know that the instructor is, like, not having their best interest in mind. And it's kind of hard, because it's like, if you love math, but then, like, you have a hard instructor that, even though they are challenging you, you just feel like you're just doing problems for the sake of basically not breaking through a wall. It's as if, like, you just do the problems and there's nothing but a crack in the brick wall that the instructor has given you. It just feels as if, like, you ask yourself, like, why am I even doing this anymore? I mean, some university students, they're like, oh, I'm doing this for a grade. And I think that's the only way that these type of math teachers stay in, like, I guess stay in their instructor seats. Like I know that's not the proper term to use, but I'll use it. It feels as if like you have to constantly try to, like, it's okay to push yourself, but at the same time it's like pushing yourself to the point where it feels like it's exhausting. That's when it gets a little bit that's when it gets annoying. And not only that, it can also get very stressful. Hello, Juyi. How are you doing today? What's the best part of your day so far? Welcome to the YouTube live stream. So we have 9 here. We have 24 and 16. So we have 4 here, and so if we have, yeah, then that will be 12. So yeah, because then that will be 12, that will be 12, and that will make it 24, and then okay. Alright, so we're left with 4/3 on both sides, so that is easy enough. X. And also, guys, if you like math, physics, or you just want a study stream to like keep you busy while you're doing stuff on your computer, you know, consider dropping a sub if you're watching this on YouTube, along with hitting the like button. And if you're watching this after the live stream, hit a comment down, put a comment down below and tell me what I can do to like improve and everything like that. So yeah, if you're watching this on Twitch, you know, drop me a follow. It really helps my channel, and it really helps me motivate myself to do more math with you guys, as well as physics. Well, it's 3 a.m. right now, so I'm watching you do math. Oh, okay. So you mind if I ask where you're from, since it's 3 a.m.? I don't like math, physics. Hello, Tenzin? Nice name, by the way. Well, if you have to do a project on the side, you know, you're more than happy to chill with us, Tenzin. And hopefully I'm pronouncing your names right. Okay, so let's see. We already saw India? Okay. Actually, whenever I go live on YouTube, like, I always encounter a lot of people from India. Hello, Goofy. How's it going? Well, it's not really a lesson. Like, for me, like, this is just my journey. It's just me trying to do math problems so I can be productive at my love for mathematics. Like, I mean, I will do the best of my ability to, like, if someone asks me, like, I guess a basic math question, like something from calculus or something from algebra, I would do my best to, like, try to answer. But of course, like, a lot of my friends in chat on Twitch, they're, like, more equipped to do, like, math problems than me. I'm having a look at homomorphisms. Oh, nice, Goofy. Like, why are you looking into that? Like, what are you trying to do? Are you trying to program something? Are you trying to, like, oh, in string theory? Oh, nice. Actually, Goofy, are you doing a PhD in physics? Or are you in a grad program? Because I'm trying to remember exactly what was it. Because a lot of, like, you guys on Twitch that, like, kept up with my streams, like, sometimes I know some of you are doing PhDs in things, but and master programs in things, and I always lose track on who's doing what because it's, like, almost similar. Currently working on physics. Okay, cool. For masters, okay, gotcha. Because, like, there was another person, their name is Grandma Ursula on Twitch. They are doing masters as well, but they want to create, like, a formal, like, mathematical setup of mathematical physics, I think. And I thought that was a very interesting project that because, like, they don't know if they're gonna do it as, like, their thesis for their PhD, because they're also working on their masters. But that's cool. I would love to do a PhD. like, you're doing something on string theory, which is like kind of getting close to which is theoretical. So I think that's really cool. Actually, I want to know your progress in that, because I always wanted to learn string theory, but I don't have the mathematical rigor to do that yet. So plus, oops. Oh, this one's gonna be imaginary solutions, aren't they? Yeah, they're gonna be imaginary solutions. So minus 25, and then we are left with 5i. Yeah. Okay, so now we're gonna be left with a cosine 5x plus b sine 5x. I believe that is the setup. Something on the cosmos related to string theory and knot theory, and yeah, because like I also wanted to learn knot theory as well, because I know it's related to string theory. Yeah, I'm like really interested in what you and Grandma Ursula like discover in your research, because it's like you guys feel like you guys are like on the borderline of the frontier. Lagrangian mechanics, yeah, okay. Yeah, I know like Lagrangian mechanics is basically the amount of total energy. Yeah, it's basically the kinetic energy minus the potential energy. And then the Hamiltonian is basically the total energy, which is basically the kinetic energy plus the potential energy. But I haven't gotten to the point where I can actually like do the math involving those processes yet. I mean, I'm getting close, because like I'm just learning the basics of differential equations. I have to actually learn multivariable calculus too, actually. In addition, I also, like, once I understand like multivariable calculus and a little bit more on linear algebra, I'll probably like do partial differential equations. So I think this is, so at this point, I don't think we can factor this. So, I mean, we can, but I don't know why my brain's drawing a blank here. Because I think it's because we did this, and I'm like, oh, we might as well do it anyway. Minus 16 or 9, and then that leaves plus or minus I 4 over 3, and then we're left with a plus cosine x, and then b sine 4 over 3x. Okay. I think that is about it for these problems. Now, I have to actually find the solution so I can check these. So we want the homogeneous ones. So, all right. So I'm going to take a look. Here it is. Number 1. Did we get number 1 right? Yes, we did. Awesome. Did we get B right? 5, 3, yeah. Okay, did we get C right? Oh yeah, that's right. Oops, I almost forgot. Yeah. Oh, that's interesting. Because they wrote it as A. They wrote it as A plus B. Because I always thought the lower term would go in A. Unless it doesn't matter. Because the way they wrote it was like A plus Because I forgot that when you take it... See, I always make the smallest mistakes when I least expect it. No, I am not in Japan. Well, why you ask, Tenzin? Something similar to Lagrangian mechanics, homomorphisms, or for perhaps galaxies that merge, or how to predict the shapes of the merge of galaxies. For example, the Milky Way and Andromeda for Andromeda in predicting its shape after merging, after being merged. Oh, okay, interesting. Yeah, it's 8 p.m. It's 8 p.m. on my side. No, it's okay. It's okay. I'm just glad that you are here and just like chilling out with us. That's interesting, actually, because I would think that 0 would be in B, not in A, unless it doesn't matter. All right, let's see what D is. Yeah, we got D right. Yeah, because the way they wrote it is like, it seems like A is the lesser of the exponents. Yep, we got A right in this question, and B, yep, we got that right. So I think I'm doing pretty well with these homogeneous linear differential equations. So we're making progress, which is good. Which is good. Yep, we got this one right. Awesome. Now the last two. And the last two, yes, we succeeded. Okay, at least I know I am pretty decent with this part. I'm not gonna say I'm good, because obviously that would make it seem like I'm good with every type of second order homogeneous equation, which I probably am not, but at least I'm getting a little bit better with the homogeneous second order differential equations. Just pardon me, guys, I'm just gonna take a cough drop. I always take a cough drop whenever I'm streaming, because I sometimes yammer a bit. Oh, Tenzin, thank you for the subscription. For the subscription on YouTube. I just saw it on the activity feed. Much appreciated, much appreciated. And, you know, positive vibes to you for sending the subscription. Because I know, like, a lot of people go onto YouTube to watch, like, you know, like, if you guys like math and you go on YouTube, I think, like, a lot of people expect me to be, like, a teacher or something. And I am not certified to be a teacher. I just love doing math, but I know, like, a lot of people go online and they try to look for people doing math because they want to get better at it. But, you know, like, I don't know what everyone's skill level is, because my skill level is pretty, like, all over the place when it comes to math. Maybe not a teacher, but a sensei. Nah. I think everyone's a senpai compared to me. Okay, I think we're gonna try to do the non-homogeneous ones. But I also have to remember the chart. I think I have, like, let me see if I have the formula sheet for the not here. Do I have it here somewhere? Probably not. I have to look for it. Integration formula sheet, differential formula sheet. No, this is not it. Oh, hello, Balalaika? Hopefully I'm pronouncing that right. I'm not good at math, but I love watching so far. Oh, thank you. Balalaika. That's a really unique name. Hopefully I'm pronouncing it right. But how are you doing? How are you doing? Is it okay if I call you Bala? Just to make it short and just make it shorter and like easy to just like address you. But if you want to just me to continue using Balalaika, I will do that. I want to make sure that I address you the way you want to be addressed. It's just a name from anime, but thank you. Oh, okay. Which anime is it from? I actually love anime, but I don't watch like the mainstream stuff. Trevor? Okay. I guess I'll address you as Trevor then. Whenever you come on. Like if you're able to catch the streams, I mean, of course. Because if you want to like continue catching up with us on the stream, you know, hitting the sub button, it will let you know whenever I go live. I go live on this channel like Monday to Wednesday, so Monday, Tuesday, Wednesday. Always at the same time. Like usually 2 p.m. for me to 4 o'clock p.m. Eastern Standard Time. Oh, Black Lagoon? Oh, okay. I still haven't watched that. Oh yeah, what was I doing? Oh yeah. We have to do homogeneous. I have to find that chart because there was a chart that like is this it? No, this is not it. I gotta find that list. This is the Laplace transforms table. Laplace forms list. This one I have. Maybe it's this. No, this is not what I'm looking for. Maybe it's the differentiation list. No, this is not it either. I remember there was a sheet that allowed me to see it. Is it this one? Oh yeah, this is it. Okay. Finally, I found it. Because I haven't fully practiced non-homogeneous second order differential equations, so I kind of needed that because I needed to remind myself what are the other parts that are needed for it. So okay, so let's just get into it. Sorry to keep you guys waiting. I was just scrambling to find like a piece of document and I was like, oh wait, where is it? What is it called? So according to what we have to do, we have to solve these like we were doing with homogeneous equations, homogeneous second order ODEs, and then we have to apply what we have in here depending upon what we have in the equal sign. So let's do that. So m plus 6, m plus 5. And let's pretend it's equal to 0. So then I think we're just gonna have these two, and then m will be minus 1 and m will be minus 5, and since we have two roots, this will be a plus -5 plus b e to the negative x. Okay, so we'll keep that in mind. So now we're gonna have to do the tough part, which is this side. So according to this, y is supposed to be equal to lambda, and then we're supposed to take the derivative of x from this, and since it's just lambda, then that means it's just gonna be 0. And then like the second derivative is obviously going to be 0 at this point. So in this case, we're just left with 5 5 lambda, and then we divide 5, and then lambda is equal to 2. So in this case, we're going to have to add lambda to this whole thing. So what we have is, and there's no, what kind of ODEs are you solving? So right now we're on a second order non-homogeneous ODEs. So actually, like before, when I was like trying to do ODEs, like I'm not really good at focusing, like continuing on the mile. I just basically get back into it when I find it interesting or I find a new strategy of how to study it. I took a crash course in differential equations, like they basically said like, oh, differential equations in a day. Obviously they didn't teach you everything, but the bare basics, I was like, oh, okay, I grasped this idea. So I believe that this is our differential equation. Now, now the thing of it is that I don't know if there's supposed to be an x at the end of 2. I don't think so, but let me see here. Okay, I need this sheet. I think we finished this. Yeah, we finished this. And we finished this sheet, so I can just get rid of this. So non-homogeneous solutions. Here we go. Okay, yeah, it looks like that's the way you solve it. Okay. So we got that problem. Okay, so we're on to the next one. Because this involves practice, so we're going to have to keep practicing until we feel a little bit confident about it. And hopefully, like, for anyone that has more experience with differential equations, like, the thing that I learned in differential, like, at least the little crash course I learned, is this strategy of doing second order differential equations, the integrating factor, as well as separable differential equations, along with some initial value problems involving both techniques. Now, of course, they didn't teach anything like the Bernoulli or the, what is it, I think it's called the Wronski. I think that's what it's called. I probably have to practice that too, but they didn't teach anything about that. And I think like the reason why they didn't teach it is because they're trying to teach it to people in a day. So I think they didn't cover that. I think it's called the Wronskian. I think that's what it's called. They didn't teach that method. And so I don't know if the amount of differential equation knowledge that I have right now is enough for partial differential equations yet. So I feel like I'm not going to rush into it yet. But I do have some linear algebra knowledge, so I'll try to implement that. That's insane. What does this help solve if I can also ask? If the answer is super long and convoluted, you don't have to go into too much. I'm just a noob. No, it's okay. So the reason why partial differential equations are important is because, well, actually differential equations. I don't know if I said partial differential equations by accident. But the importance of differential equations is that every single problem in, I guess, like in all walks of life, whether it be economics or physics or engineering, it involves like rates of change a lot. And the reason why you have differential equations is because you know that a rate of change is related to another rate of change. But the thing of it is that you don't know how those rates of change relate to each other. In addition to, like, if you know the relationship of these rates of change, how can you set it up so you can get an equation that tells you the absolute thing you need? And I think that's what differential equations usually helps out with. It's very difficult, but at the same time, it's very applied. I mean, that's what inspires me with differential equations is physics. Hello, Shirhan. Hopefully I'm pronouncing your name right. If I'm not pronouncing it right, please correct me and tell me how I can pronounce it so I can address you properly. Because I want to make sure that you guys feel safe and respected here. And I want to be able to address you guys properly, the way you would like to be addressed. But what's the best part of your day so far, Shirhan? But thank you for asking the question, Trevor. That is, I'm like, whenever chat is being interactive with questions, I really like it because it shows that you want to be actively, like, even though you're probably not as passionate about math or physics as I am, at least you're just curious about it. And, you know, I try my best to give short answers so it doesn't feel like it's overwhelming. Because sometimes, like, when I talk to my friends, like, you know, I try not to ramble on about my love for the subject because I know they're not really passionate about it. Which is not their fault because a lot of people have different priorities. Okay, so we got, so I'm guessing we're gonna have 6 and 2 here. So we're gonna have m to the positive 2 and m to the positive 6. So we're gonna have a 2x and then b e to the 6x. Okay, so we'll keep that in mind. Next, we will do the other side. And I think this one, it has to be lambda plus something x. I think it's mu of x. Let me check my chart. This is the reason why I need the chart, because I don't remember the higher values. Yeah, it looks like it is like mu of x. Okay, and that is okay. Yeah. So, all right. Now, so this is supposed to be y, not 37x. Okay, so that's supposed to be y. Now we have to take the derivative of that. So that's just going to be mu, and then we take the second derivative, which is 0. So now for the fun part. So now we're gonna have to put everything that we have in this equation into this one that we're gonna write. So we're gonna have 8 mu, negative 8 actually, and then plus lambda plus mu x, and that's equal to 36x. Now we're just gonna 12 lambda plus 12 mu x, and then mu here, then 6, like so. And now we're gonna do 36x minus 12 mu x. Then we have on this side, like so. And we can factor out the x. So we have 36. Actually, what we can do is that we can remove 12. So we can factor out 12x from both. So this will be 3. And this will be mu. Yeah, that makes it much easier. So at this point, now we have to basically get everything equal to 0 on this side. So what will make this 0 is basically if mu was equal to 3. Alright, so now we have to get this side equal to 0. So to get lambda. So then we have negative 24, 12 equals 0. So the only way to get that is if lambda is equal to 2. So in this case, we have to add 3 and 2. Because, well, actually, we have to put it like this, so now we are left with y is equal to a plus e 2 and 6. So I could have just copied that and just pasted it down here, but I'm like, no, I'll just scroll up. I'll make the effort. Okay, plus 2, which is lambda, and then plus mu 3, which is x 3x. And I believe that is the solution. So I'm going to check my solution sheet, see if that is correct. And yes, we got that correct. Nice, nice. Now I know the more we go further into this sheet, it's going to get a little bit more hairy, but I think we're gonna basically just do our best and see how far we can get. So. Okay, I'm just gonna take a quick drink of water. All right, so minus 8m plus 16, and let's just pretend that's equal to 0. So I guess we're gonna have, yeah, that matches. So 4, meaning that y is gonna equal to e4x a plus bx. Okay, that's the first part. Now the second part we have, okay, so since we have this side, we're gonna have y equal to lambda plus mu x, because this is just a linear setup here. So dy is equal to mu dy dx to the second derivative is 0. So now, okay, I want to make sure that I wasn't doing, because this problem and the problem we did before almost looks the same. It's just one number is, a couple of numbers are different. Hey Fox fam, how's it going? What's the best part of your day so far, my friend? Anyway, getting back to what we were doing, so we had negative 8 mu, and then plus 16 lambda plus mu x. That's equal to 8x plus 12. Alright, so do this. We have 16 lambda plus 16 mu x, 8 plus 12. Then we'll move all the constants to the to one side and all the variables on another. So we'll do this. 8 plus, oh no, that's minus. It's supposed to be minus 16. Minus 16 mu x. Just boiling the kettle for some green tea. Ooh. Sounds lovely. Sounds lovely. I haven't been drinking tea in a while because of the hot weather. I probably should though. But then again, I don't want my body to get overheated. So we'll take 8x, so 1 minus 2 mu. Oh, I don't like the way that mu looked. Mu. And if that was equal to 0, so then we would have mu equaling a half. Now, if that is equal to a half, then plus 16 lambda minus 12, that will also be equal to 0. So equal to 0 as well. So at this point, oh, that would be negative 16. So lambda would be 1. Oops. I'm glad you love differential equations, Femvox. Hopefully you enjoy the stream, seeing me solve these. We actually were doing Laplace transforms, like I think like the first part of the stream. We were using the actual definition of Laplace transforms, and I'm like, wow, that's very tedious to do. I only did up to like t squared, and I was like, oh yeah, this is a lot of work. No wonder people say look at the table. So we have this, so what are the numbers again? Oh, 4x, okay. So 4x, oh, whoops, that a doesn't belong there. So a plus 4, plus bx, and then plus 1 plus half x. And I think that is our solution there. Let's take a look. Here it is. Yep, that's our solution. Cool. So we're making good progress now. Okay, next one. This one's an E. So for D, I think like the fun of math is once you get a concept and you do it over and over again, you feel as if you're like, you know, those, like, I guess in movies, like for me, I always feel like I'm like those professors that are just doing the calculations to figure out the secrets of the universe. Even though it's just scribbles, like they don't probably have nothing to do with the physical world. I guess like solving any math problem will give you that adrenaline rush. So it will be 9 plus m squared, which means, ooh, this one's gonna be imaginary. Yeah, this is definitely gonna be imaginary. So it's gonna be m plus or minus 3i. So in that case, we don't have a real part, so we're gonna be left with a plus cosine x plus b sine 3x. Okay, no problem, VoxFam. Thanks for the lurk. Okay, now we got an so I think this one is supposed to be lambda times e whatever e is. So I'm going to take a look. So e is, so yeah, it is lambda, like so y is supposed to be lambda times e to the 3x. I think that's how it's supposed to be. And now, if we take the derivative of that, that would make it 3 lambda 3x, and then if we take the second derivative of that, that would be 9 lambda. Now we gotta put everything. We gotta put everything together. So the second derivative, okay, so we don't have the first derivative, so we don't have to worry about that. So we have 9 lambda 3 to the e to the 3x plus 81 lambda 3 e to the 3x, and that's all equal to e to the 3x, 15 to the 3 to the 3x. Okay. Okay, so basically we have a lot of stuff that goes with each other. So now we have to solve for lambda. And the thing is that, well, actually, it's probably better for us because when we think about it, it's just lambda. So we can probably do this trick. So lambda. Then we'll minus 15 like that. And I think we can take 3 from every one of these. So that way we reduce it a bit to help us out. Oh. Hit my fan there for a second. Divide by 3. That's 27 lambda. And then 5 ux. Yeah, we'll just divide 3 to basically remove it. So 3 lambda. And I think now we'll combine the lambdas together. So that will lead us with 30 lambda. I could have done that at the beginning, but I was like, maybe save that for later. And then this 30, we can take 5 out. So this would be 6 lambda. And then 0. Now we have 6 lambda. Oh, why did I put a negative there? It's not supposed to be there. 3x. Okay. So I think now we're just going to have to get lambda by itself. So now we just have to minus 6 lambda. And it just becomes pure algebra at this point. So 6. And then these two will cancel each other out, leaving us with lambda is equal to 1 over 6. And if that is the case, if we take our original equation, or our first part of the equation anyway, so it's a cosine 3x plus sine of 3x. Hopefully that is correct, right? Yeah. Then we have to add cosine 3x. Not cosine, e to the 3x. Okay. Because the e, the y is supposed to be this, so we just add that there. And I'm going to double check to see if that is the correct solution. Hold on. Oh, yeah, oops. Yeah, I did I basically took the square root too early. That's what happened. So it's supposed to be 9. Oops. See, that's what happens sometimes. You make these small mistakes and you don't catch it. But that's usually the small mistakes I always make whenever it comes to math. I always forget that I do some stuff early. But we got the technique right. We just put in the wrong numbers by accident. Sometimes that happens, guys. I'm only human. If you guys are able to do that very fast and you can check your work without worrying about like a flaw in there, like, you know, I give you credit for that. For me, I can't do it, as you just saw. Okay, so now we're on to E. Yeah, but these problems are pretty fun. I'm not gonna lie. I have to find ones where they have these problems and they involve physics problems. I think that would be like an energy boost for me, because it feels like I'm actually working with differential equations that are dealing with the universe. And also, like, guys, if you like math, if you like physics, or if you just want to study stream to keep yourself productive while you're doing stuff on the computer, you know, if you're watching this on YouTube, like, drop a sub if you can. As well as, like, if you're watching this after the live stream, you know, hit the like on the live stream, in addition to leave a comment down below if you're watching this after the air date. But if you're on Twitch and you like math, you know, just drop a follow if you can. Puik. Sorry, I didn't see that you just when you put the like. I think you were meant to type lurk, and I didn't see that. It took me a while. I thought that was Femvox basically typing in lurk 2 times, but they just put an F instead of an exclamation point. But thank you for the lurk if you're actually lurking. Anyway, let's get back to this. So -4 plus 5. If that is the case, then 5. Oh, hold on. No. Do we have to use the quadratic formula for this? This is -4 plus 5. Yeah, I think we might have to. I might have to use the quadratic formula. How's the problem written? Okay, yeah, the problem is written exactly like that. Okay, so I guess we're gonna have to go back. Now, this part, let's see, we have, so this is gonna be 16. So this is gonna be 16 minus 4 times 5. Oh yeah, we're gonna have an imaginary. So it'll be like, yeah, it'll be -4. So then we're gonna have like plus or minus 2i. And then if we divide that, then we're left with 2 plus or minus I. Okay. So now we actually have like, so it'll be e to the 2x, a cosine x, sine x. Okay, now we got to do the difficult part. We have a polynomial. So, polynomial here. Then, if that's the case, then we have to have y equal to, I think it was lambda plus mu x plus nu x squared. I'm going to check my sheet just to make sure that that is correct. Yeah, I think that is. Yeah, it is. Okay, so now we have to take the derivative of that, which is nu plus 2 nu x, and then the second derivative is 2 nu. Okay. putting this all in the formula. So minus 4 mu, and then plus 5, which is lambda mu squared. And the rest of that is 27. Oh no, that's 25. So it's 25. Yeah, 25 x squared 7. Okay. Now to combine all of them. Oops, that should be a negative. Negative mu. And 5. Okay. This one's going to be a little bit cumbersome, but we'll do it. So these are considered constants. We'll put the 5 here. Oops, not 5y. 5 lambda. And then we'll have minus 8 mu x plus 5 mu nu x plus 5v x squared 25 minus. Okay. Now, time to put the x's together. So I think we'll put plus 7 here, and then we'll have 25 squared minus 25 nu x squared minus 5 mu x, and then plus 8 mu. Okay. Now we have to solve for we have to solve for 3 variables. Now this is where it's going to get a little bit tough. Oh, hello, Muslim? 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 Interesting name. Is that, hopefully I'm pronouncing it right. Is that, Obsidian? I don't know what that is. But how are you doing? How are you doing? What's the best part of your day so far? Okay, we can't combine the squares, the x squares together because obviously the nu is there. Do we have to do grouping? I feel like we might have to do grouping. So x squared, that would be 5 minus nu. Okay, so I think that will give us nu. This one, so this one's just purely x, so we're left with 5 mu nu actually, since I took out the, yeah, we'll take out the negative, make it simpler to use. The software you're using, I'm good. How about you? I use OneNotes for math notes. Oh, I'm using XCalDraw, yeah. But like, what type of math notes do you take? I'm guessing, are you like an undergrad? Are you a graduate student? Or are you just someone that likes to do math? Because I'm just a person that likes to do math as a hobby. Yeah, this is where it's gonna get a little bit messy. I mean, if we make this 0, let's say if we make equal to 5, and then this will be 40, and then this will be 8. So then we'll have 2 times 5 minus 4. Now we just have to figure out lambda here. So then we have 10 minus 32 plus 5. So these two together, negative 22, 5, 7. Then scratch that. 15 plus 5. And all this has to be equal to 0, so in this case, lambda would be 3. I like to do math also as a hobby. Are you saying you're 12 years old, or are you saying that you're in your 12th year of high school? I'm guessing you're saying you're year 12 of high school. I guess like in the States we call it a senior. Like you're in your senior year of high school. So we have alright, so I think for the y we have, so this one's supposed to be plus 8, yeah, plus 8x, then plus 3x squared. Which one was I correct on? Muslim. Like, are you? I'm guessing you're in your 12th year of high school. Is that correct? I don't want to get my facts mixed up. That's why I'm asking. So where was it? Oh yeah. So what did we get for the first part? Okay, so it's supposed to be y equals e to the second power cosine x plus b sine x. Okay, 12th year of high school. Okay, I see. Nice. I mean, what math are you working on in high school compared to like what type of math you like to do for fun? And I think plus this. So I don't know if that's the correct answer. I'll just put it in a box. I really love ODEs, PDEs, but I'm not good at it. Yeah, I'm the same. I haven't even touched PDEs yet. I'm starting to get a little bit better at ODEs, but I'm only getting the basics. I'm not really doing like the more technical stuff yet. I'm only doing like the broad strokes. So this one is letter E. So let's see. Oh. Oh, oops. I wrote 3 by accident. It's supposed to be 5. Oopsie. I wrote it right here, but I didn't write it down here. Oopsie. That's what happens when you do math for a long time. Is that like you feel like you got it right, but then you forget that there's one detail you overlooked. But I think we did pretty well. We just missed one number, which is always what happens with me, is that I would write the wrong numbers down sometimes. I'm pretty sure like a lot of people that do math face that issue. But at least we managed to solve that one. That one was actually pretty like long. But I think that's pretty good though. School pre-calculus myself, middle of algebra 2. Once I jumped from U substitution to differentiating under the integral sign. Oh, I don't know how to do that. Differentiating under the integral sign. Like I've seen people explain it to me, but at the same time, it's like I've never done a problem that involves it. Maybe I should probably do one day. Because like, whenever I try to look up YouTube videos that explain it, I get a little confused because I'm like, wait, what? Maybe I just didn't put the time to actually try to look into it. I gotta find like a good format that explains it in a way that I understand it. Plus m minus 12. Okay, so this one. So I think we'll have 4m, 3 plus m. Oh no, it's supposed to be the opposite. Okay, so it's gonna be plus 4m. 3. So then 3. And then negative 4. Then we have 2 roots. So we're gonna have e to the minus 4 plus b 3ex. Okay, but that's good that you're actually learning material outside of your classes, because that way you'll be like better prepared to like do higher levels of math. Are you planning to major in math in university, or do physics, or something involving with math, or you're just like, nah, I just like math as a hobby, I'm gonna do something else in university? I assume you want to learn mathematical topics to complete a complete understanding, not just to apply them. Honestly, I'm not very particularly sure. For me, it's like, I like math when it has like a physical application, but I think once I get used to a mathematical technique, I just find it fun to like solve them, as long as it's not too tedious or too overwhelming. So I guess like for me, my interest in math goes like in both ways. I like physics and mathematics together, and I like to learn math because I want to be able to like understand the world and the universe in a very mathematical way. But also I want to learn physics because I want to learn like how the behaviors of nature can be written in a mathematical format. So we got 12. Oh, okay, so this one's going to be a little bit easier. So we get lambda to x. So if we take the first derivative, that would be 2, like that. Okay, 4 lambda, like so. Oh no, did you finish the Laplace transforms? Like we just basically did 2 because we were doing the definition of the Laplace transforms. But maybe I will go back to do one Laplace transform problem. Welcome to the chat from YouTube, Harish. Hopefully I'm pronouncing that right. Or is it Hirash? Like hopefully I probably mispronounce your name, and I apologize for that. Like, please let me know, like, how to pronounce your name correctly. And how's your day so far? What's the best part of your day? Okay, so... But probably after we finish this problem, I'll probably do another Laplace transform problem for you. Because it seems like you wanted to do a Laplace transform problem. Hiresh? Did I pronounce it right then? Hopefully I'm getting close to the pronunciation. Because I want to be able to address you properly. Because, you know, like, I want to make you guys feel safe and respected in the MathSpellBook domain. Okay, so let me just go back to what our equation says. Okay, so we're going to have to write for lambda e to the 2x, then 2 lambda, then minus 12 lambda, and I think, dang, we're running out of space. Okay. Doing PDE is probably the best part of my day. Oh, nice. Maybe you can teach me a thing about PDEs. Because, like, for me, I haven't even started PDEs. I want to get started on them, but I don't know how much I'm lacking with experience when it comes to those. Because whenever I read a PDE book, it just starts out with the heat equation, and I have to read more than I actually analyze. And I'm like, I'm not doing any problem solving yet. But I have to, like, know every part of the PDE, I think. That's the reason why it just feels like more strain on my eyes. Because I know PDEs are like more analytical than ODEs. Oh wait, we can add them all together. Okay, so minus, we got 12. Oh, okay. Oh no, why am I putting the lambda down there? That's not supposed to be there. So minus 6 divided by, that will lead us to 2. It'll lead us to negative 2. Okay. So, okay, so that's lambda. Oh wait, what am I doing? We can cross those out. Oops. Okay, so now, here's that. Okay, so a plus 3x. Then we're gonna have to add plus. Oh no, it's a negative. Negative 2. Yeah. And I believe that is it. Oh, we have a 2 here, so. Oh no, we have a lambda here. Okay, okay. Like, I almost, like, psyched myself out. So, I just want to make sure that we did this correctly. So, yeah, so we had that was 6, that's still 12, negative 12, and then basically we get negative 6 because this is negative 12, and then we divide that and we get negative 2. Okay, so I think that's pretty good. I think that's the problem. I'm going to take a look at the solution. This is number, I think this is F. Yeah, this is F. Okay, I think we got it right, because like when I look at the solution, like they left the lambda there, and I'm like, that's not supposed to be there. But yeah, I think we did it correct. So, okay, so Hirosh, I believe you were asking about Laplace transforms before, so I think we'll probably do one more problem. Yeah, we'll do one more problem involving Laplace transforms, because it seems like you wanted to do, like, it seems like you were kind of excited to do Laplace transforms, so I guess we'll do that. Do I still have the Laplace transform questions? Okay, so instead of actually doing the one involving the definition of the Laplace transform, I think I'm going to do the one involving the chart. So, so for question 2, using, oh, that is so messy. Usually if you have a good grasp of calculus 2, then you can like start with metas math, introduction topics, a little bit simpler I found. Oh, okay. I'm guessing I'm gonna have to Google that, right? So it's like metas math introduction. PDEs. Let's see. Oh, here we go. I'll probably save this in my favorites if it's simple. Okay, it looks like it's a document. Oh, it looks... Okay, it looks pretty straightforward. Okay, I'll definitely take a look at this. Thank you for that, Hirish. Anyway, you wanted what is it? Linear transforms. Let's get to that. So we're using the table to find the Laplace transform. So we got plus. Okay. Now, so what I remember is that if we have t, then we have to do this, the factorial, and then s will be the n plus n in that case. Not a literal app, but just a community within the posting math videos and solving problems and so on. Oh, okay. Thank you for the explanation, Muslim. Much appreciated. Like, if there's any way to make myself like learn math a little bit easier, any application helps. Oh, I see. I prefer more abstract topics like real analysis and proofs. That's fine, because like for me, like I find real analysis interesting. It's just doing proof writing takes a longer time for me because I'm still not used to it. But I do like the way how math is done involving definitions and stuff. Like you use definitions to actually prove ideas, and I think that's the cool part about like proof-based math. Actually, like a majority of my friends that are into math, they love proof writing more than like, you know, putting math into applications. Like I want to learn proof writing because I want to be able to like prove ideas like within like physics, but in addition, like, you know, maybe prove ideas in math, and maybe those mathematical discoveries will lead to somewhere where it's applied to physics, you know. It's like, I think that's the most interesting thing. So I think for this this will lead us to 3t. Oh no, that's supposed to be s. So it's like 3s squared plus. Okay, so we have a square root here. Now, I don't know if we can do a factorial of a fraction. I think we can. It's just that I just never experienced doing that. But then again, I guess I'm gonna have to look at the table because I don't think I've encountered that. Oh yeah, the Laplace looks way different. I was gonna write something different, and I'm like, no, that's not the way it looks. Oh boy. Luckily I looked at the chart. So it's supposed to be just, wow, it's the square root of pi over 2. Dang. Talk about your complicated ones. I actually have to look up the physical applications of Laplace transforms. I know like Laplace transforms, they help you deal with data, especially when it comes to waves, like sound waves and all that stuff. But I still have to like look up the details. Like, you know, why is it that you have to transform, like, I'm guessing t represents time while s is supposed to represent something else. I'm not gonna say space because I feel like that might not be a good comparison for me right now, because I still lack physics knowledge when it comes to that. Physics is greater than maths. I mean, like, it depends on who you ask. Because some of my, like, for me, it's like, I feel like I love both, and I'm starting to love both equally. Before, I think I would have said that physics is much better because it actually has, like, more, like, I guess, like, more virility because it's a science. But when I get more into maths, I find it very interesting that maths feels like it's kind of like developing more and more, and then suddenly they just find application. Like someone who specializes in something finds an application for a math that seems very abstract, and I think that that's the exciting part. It's like you find a pattern in the universe that basically says, hey, this math process happens within this frame, you know? Okay, I guess that will conclude it for today's, guys. Hopefully you like that that Laplace transform problem. But I just find it very interesting that the Laplace transform of the square root of t is actually like just the square root of pi over 2s to the 3 over 2. I find that very, very interesting. S is displacement? Okay, cool. Yeah, because like I didn't want to say that it's space or anything, like because that's the way I would probably remember it, because it's like, you know, t is time. I love physics, so it's like space time. So I would put like, oh, s means space, but in actuality it's like displacement and stuff. So, you know, for me it's like like I guess it just makes sense to make that comparison, but it probably isn't correct. But yeah, thank you guys for joining me today. Like for all those that were in the YouTube chat, thank you for joining in. Always appreciate you guys stopping by. For all those in the Twitch chat, the same goes to you. Always appreciate like seeing all you guys let math and come in and just basically like ask, like basically just talk to me while I'm just doing math problems. It just feels like we're like in a like I guess like an office space where we're just like chatting to each other about like what's your latest what is your latest discovery within math and stuff. And it's like cool, like, you know, I just discovered things about Laplace transforms that I didn't know. It's like nice. It's like, what did you discover? Like you ask each other, it's like, what did you discover? Oh, I discovered this part about PDEs. I was like, nice, you know, like we all support each other and we all like just congratulate each other on our wins in math and physics. I will try to do more physics problems further down the line, I think, because I have to like actually get to learn more physics, because I think I'm applying more physics when it comes to my thinking, but doing problem solving, I have to actually apply I guess the technicalities of like the subjects that I know in physics. Like for me, when it comes to physics, I remember the formulas, but applying the knowledge of like the details of like what those physical ideas mean, like, you know, the definition of force and all that stuff, that I still have a problem with. So I have to learn not to think of physics in a mathematical way, and I still have to think about physics as a very scientific, physical way. But yeah, so like I said, if you guys are on YouTube or on Twitch, if you're on YouTube and you like math and physics, or you just want to stream to, you know, just study too, or just like do your fun projects on like through your computer and stuff, and you need a little bit of background noise to like just keep you studying or keep you like working at the projects you're doing, you know, consider dropping a sub on if you're watching this on YouTube. And if you're watching this after the live stream, you know, like hit the like button and comment, you know, along with subscribing. In addition, for people that are on Twitch, oh yeah, and also on YouTube, all the links will be in the description down below to our Discord server, as well as my Twitch channel, as well as my gaming Twitch channel. I have 2 different channels, so if you want to see me play video games, like my Uncle Talks channel's link is also in the description down below. If you're watching this on Twitch, you know, drop me a follow if you like math or physics, or you just want like a study stream to keep yourself productive, whatever it is you're doing. And yeah, that will do it for all today, guys, and we will be back tomorrow. And always remember, everyone is precious. You guys are just as precious as everyone else, and I will see you guys in the next stream. So take care, guys. Bye bye.